Okay, so this video is going to be 7.5, dividing powers with the same base. So we've multiplied powers with the same base, we've done power to a power, so this time we're going to be dividing powers with the same base. So dividing powers with the same base, sometimes they're expressions, sometimes they're numbers, but there are easier ways to do things like this. Okay, so the rule is that we're going to subtract our exponents. So when we're dividing, we're going to subtract our power. So like this, a minus b is going to give us what we want. So last time when we were multiplying things with the same base, we added their exponents, so we did a plus b. Well, since division is the opposite of multiplying, that's why we're subtracting here in the center. Okay, so if we're dividing things with the same base, if I wanted to write this out the long way, it'd be 3 times 3 times 3 times 3 over 3 times 3. So this, we would normally cancel out the ones that are the same. So since these are the same, we can cancel them, and since these are the same, we can cancel them. So that's going to give us 3 squared. Well, if we subtracted 4 and 2, that's still going to give us this 2 on top as well. So if we take a look at this next one, 16 divided by 4 is going to be 4. And then 4 minus 18 is going to be negative 14. Okay, well when we have a negative, we got to drop it down to the bottom. So it's going to look like this. Okay, so this next one, 3 plus negative 3 is going to be 0. Or 3 minus negative 3 is going to be 3 plus 3. So an easier way to do this, I would just bring this up top first. So move around your negatives first. So it's going to be c cubed times d squared over d to the 4th. So we add these because we're multiplying them. So we're going to get c to the 6th. And then 2 minus 4 is negative 2. We've got to flip it to the bottom. So we're going to get c to the 6th over d squared. Okay, so this one, we got those that we're going to do first, but I want to move this t first to make it positive. So I'm going to get 3 squared m to the 4th, t to the 6th, t to the 5th, 3 to the 5th, m to the 7th. Okay, I'm going to erase this over here so I have a little bit more space to write. Okay, so I'm going to continue over here. So then 2 minus 5 is negative 3. 4 minus 7 is negative 3. And then we add these, so 6 plus 5 is 11. So then we would have to drop these below. So for this, when we're normally looking at these, let me erase this top one so again I have some space. So when we're looking at these, if I have 3 squared over 3 to the 5th, since this 5 is bigger on the bottom, that's where it's going to stay. Whichever side is bigger is where it's going to stay. So if I think of it as 5 minus 2 for this one, it's going to be 3 cubed. Well, since the 5 is bigger, we know the 3 cubed has to stay on the bottom, which is then going to flip to the bottom. Okay, so 8 divided by 2 is 4. 14 minus 2 is 12. So again, you can pause this right now if you'd like so that you can try these on your own. Okay, I'm going to flip-flop these. So I'm going to have m to the 5th over m to the 1st. 5 minus 1 is going to be 4. Okay, 3 minus 3 is 0. 12 minus 4 is 8. C to the 0 is always 1, so we're just going to have d to the 8th. Okay, I'm going to flip-flop these because I need to have them be positive. So I'm going to have 4 to the 5th, m to the 7th, t to the 5th, over 4 to the 4th, m to the 7th, and t to the 6th. Okay, so 5 minus 4 is 1, so I'm going to have, since the 5 is bigger on top, it's going to stay on top. 7 minus 7 is 0. And 5 minus 6 is negative 1. But since the 6 is bigger, we're going to just put t to the 1 on bottom. Okay, m to the 0 is still 1, so our answer is going to be 4 over t. Okay, raising a quotient to a power. Sometimes we're going to have expressions when we're going to have division and we're also going to have power to a power. So let's see how we can do this. So this, we would distribute this p to both of them. So it would be like this. And then if we can, we would subtract. But this one, they have different bases, so we wouldn't. Okay, so here's an example. If I just looked at this, so if I just had x squared to the power of 3, we would normally just multiply these to get the 6. Well, this time, we also have it on the bottom. So we also have to multiply this 6 and this 3 to get our 18, which then we would subtract, and then we would flip to the bottom. Okay, so this, we're going to put 1s for our exponents. So we'd get 3 squared over 8 squared, which is 9 over 64, because we multiplied. So again, I don't have exponents, so I'm going to put 1. So 3 times 1 is 3. 3 times 1 is 3 again. 2 cubed is 8. And that's all the way reduced. Okay, so this is a negative 1. So if I have a negative 1 and I could just multiply everything. But since everything's going to become negative, I could just flip-flop these. So first I'm just going to show you what it's like if I just multiplied everything. So it'd be 1 times negative 1 is negative 1. 5 to the first is 1 times negative 1, which is negative 1. And then x, 2 times negative 1 is negative 2. So all of these would flip to the top, and then this would flip to the bottom. So we would normally have 5x squared over 3. What I could have also done was automatically just flip-flop these. So I would have got 5x squared over 3 to the 1, because that negative shows that I would flip-flop everything that's inside of it. So this is going to be the same answer, because if I distribute the 1, it's going to give me the same thing. So this one, I could combine in the inside of my parentheses if I wanted. So I'd get b to the 6th over b to the 7th. Okay, I could reduce again inside my parentheses, so I get 1 over b, and then take it to the negative 5. So I have to multiply. So 1 to the negative 5 is just going to be 1. 1 times negative 5 here is going to be b to the negative 5, which will then flip it to the top. So our answer is just going to be b to the 5. Okay, so if we look at this first one, I'm going to put 1s for all my exponents. So 2 times 1 is 2, 2 times 1 is 2, 2 times 1 is 2. So I'm going to get 9x squared over 16. Okay, anything to my 0 power is just going to be 1. Okay, I'm going to flip-flop these to make that a positive exponent there. So I'm going to get 5 squared over negative 3, and I still have my squared. So I'm going to make this, since I don't have an exponent, I'm going to put a 1 there. Now I'm going to multiply this 2. So it's going to be 5 to the 4th over negative 3 squared. And then you would reduce that. Okay, I'm going to send this a to the negative 7 up top, so I'm going to have 3a squared, a4, a7, still to the negative 5. Okay, I can add all these together because they're multiplied. So 4, 5, 6, 13. So I'm going to have 3a to the 13 to the negative 5. To make this positive, I flip this down. So I'm going to get 1 over 3a to the 13 to the 5, and then I multiply these. So then my answer would be 1 over 3 to the 5, a to the whatever 13 times 5 is up here. Okay, so let's try a to the negative 2 to the negative 1. Okay, so for this, what I'm going to do is I'm going to flip this up first because I want everything to be positive on the inside first. So I'm going to get a squared. Okay, now I'm going to work with this negative, so I'm going to flip it back down to make this exponent positive. So it's going to be 1 over a squared 1. And I don't have to do anything with this because anything to the first power is itself. Okay, let's try 3 squared to the negative 2. So I could just automatically I could flip this first to make this positive here. So I'd get 1 over 3 squared squared, multiply, so I'd get 1 over 3 to the 4th.